Welcome to this video series on data fitting. Whether you are a scientist, engineer, medical professional, or a student, understanding how to fit mathematical models to experimental data is one of the most valuable skills you can have. In this series, we'll go from the basics to practical applications with lots of real-world examples. So what exactly is data fitting? In simple terms, it is a way to find a mathematical equation that would describe your experimental data. So you start by collecting data points from your experiments, and the data fitting helps you to draw a smooth curve through those points that you have collected from your experiments. But more importantly, it lets you understand the underlying relationship between your variables and help you to make some predictions. Here is the big question we face every time we look at some data. And the question is, which model fits best? So looking at scattered data points, we need to find a mathematical equation. That is a model which can describe the pattern hiding in your data. So choosing the right model is crucial for making accurate predictions, and that would help you to understand your data better. So the question is, why should you care about data fitting? So there are four main reasons for that. The first thing is to predict what's going to happen next. So once you have a model, you can predict future values from past data. What will happen at higher temperature, for example? What will happen at longer times? Your model can estimate that. And the second reason is to understand the data. So a good model tells you how your variables are related. Are they linear? Are they exponential? This gives you an insight into the underlying science, and again that helps you understand your data much better. The third reason is to quantify, i.e. that means you can measure how strong effects are. So there is not just there is an effect, but you can also know how much is that effect. And the final reason is communication. So instead of showing some random scatter plots or any kind of a plot, you can communicate your findings clearly with some clean parameters and equations, which helps you to present data in much better scientific way whenever is the platform you want to show your data in. Data fitting follows 4 steps. The first step is to plot your data. So you should always visualize your data first. And the reason because the shape of the data will tell you which model to choose. This is followed by the second step, which is to choose the model. And that is again based on the shape of your plot. So for example, is it a straight line? Is it curved? Does it have an S-shaped? All those are common kinds of models that we will discuss later. The third step is to fit and check. So often we use some kind of software to find the best parameters. And then we verify the fit, whether this fit is good in proportion to the data being measured. Finally, we interpret the data. That means we understand what the results mean in the real world. So here is a quick overview of the models that we will cover. At this point, don't worry too much about memorizing these, because we will go through each one of them in detail. So the first kind, or the first type, is the linear, which is used for straight lines. When we have curves or waves, we will use polynomial, or we could have exponential for growth and decays. And finally, we could have special models that will cover S-shaped curves and peaks. We will look into those models in detail. The next one will be the linear models.